Hi all, welcome back to Matlab tutorial on Tooth Fulcrum. This session is on how to create arrays and vectors and how to perform arithmetic and trigonometric operations on them. An array is a list of numbers or expressions arranged in horizontal rows and vertical columns. For example, if you arrange the numbers 1, 2, 3, 4 in this manner, I can say that 1 and 2 belongs to first row and 3 and 4 belongs to my second row. Same way, 1 and 3 belongs to my first column and 2 and 4 belongs to the second column. So this method of arranging the numbers into rows and columns is referred to as an array, or you can call this as a matrix. Of size, the row size is 2 and the column size is 2. So I can call this as a 2 cross 2 matrix. When an array has only one row or column, it's called a vector. If I arrange the numbers 1, 2, 3 in this manner, I can call this as a vector, because this has only one row. The row size is 1 and the column size is 3. So I can call this as a vector and I refer to this as a row vector. I can arrange the same numbers in this manner as well. So this is also a vector. Here I can say that the column size is 1 and the row size is 3. So I call this as a column vector. Let's see how Matlab creates a row vector and a column vector. If I say A equal to square bracket 1 space 2 space 3. As you can see, it creates a row vector. So to create a row vector, the elements must be separated by space. You can also create a row vector by separating the elements with comma operator. So this also creates a row vector. So you can either use space or comma operator to separate the elements. So if you check the size of A, you can see it returns 1, 3. So 1 is referring to the row size and 3 is referring to the column size. So I can say that A is a row vector whose row size is 1 and column size is 3. Now you can check the number of elements present in a vector. You can use the function numL. If I say numL of A, this will return the number of elements present in a vector. You can check the dimensions of a vector. N-dims of A will return the number of dimensions of your vector. So here it is returning 2, indicating it has a row as well as a column. Now let's create a column vector. So P is equal to use square bracket. So here the elements must be separated using a semicolon. So this creates a column vector. So if you check the size of B, it returns 3, 1, where 3 is your row size and 1 is the column size. So you have one column indicating it's a column vector. You can check the number of elements present for a column vector as well. So numL of B, it is returning 3 because your vector has 3 elements. You can check the number of dimensions as well. So n-dims of B, it is returning 2, indicating it has a row as well as a column. Now let's apply some arithmetic operations onto these vectors. You can add or subtract two vectors of same size. So let's create two vectors. Let's take A1. So we'll take the same elements 1, 2, 3. And let's create A2. Let's put the elements as 2, 4, 6. So here, as you can see, they are of the same size. Now you can add two vectors of same size. Let's go ahead and verify it. So if I say A1 plus A2, you can see your output 3, 6, 9. So how is this performing the operation? It takes the first element of the first vector, adds to the first element of the second vector. So when you add 1 plus 2, you get 3. Next it takes 2, adds to 4, so 6. Then it takes 3, adds to 6, you get 9. So your result will be another row vector holding the values 3, 6 and 9. You can perform subtraction as well. So if I compute A1 minus A2, you can see the result minus 1, minus 2, minus 3. So how is it performing? First element of A1, 1, minus 2. So 1 minus 2 is minus 1. Again 2 minus 4, that is minus 2. Again 3 minus 6 minus 3. So this will be your output if you compute A1 minus A2. You can multiply or divide the elements of two same-sized vectors term by term with the array operator. That is, if we take A1, 1, 2, 3 and we have our A2 which is created as 2, 4, 6. So if you want to perform an element by element product, A dot star, or sorry, it is A1 dot star A2. This will compute an element by element multiplication between the vectors. That is, it takes the first element of A1, 1 into the first element of A2. So 1 into 2 is 2. Again 2 into 4, 8. Then 3 into 6, that is 18. So your output will be a row vector with the elements 2, 8 and 18. You can compute division as well. So if I say A1 dot divided A2, it divides element by element. So you can see the output. But multiplying a vector with a scalar does not need any special operation before the asterisk symbol. That is, you have A1, 1, 2, 3. If you want to compute 2 into A1, 2 is a scalar. You are multiplying the scalar to a vector. So here you don't have to use the dot operator. You don't have to evaluate like 2 dot star A1. That's not required. You can simply evaluate it like 2 into A1. You can see your output is 2, 4, 6. That is 2 multiplied with 1, 2 multiplied with 2 and 2 multiplied with 3. Now let's see how to create a vector of n numbers linearly or equally spaced between two given numbers a and b. For this, we make use of the Linspace function of Matlab. If I write an expression x is equal to Linspace of 0, 10, 5. This will create a vector x with 5 elements linearly or equally spaced between 0 and 10. Let's check. So it has created a row vector whose first element is 0 and the last element is 10 and the elements are equally spaced. You can also create a vector with a range of values making use of the colon operator. For example, if I say y is equal to 1 colon 1 colon 5. You can see your output 1, 2, 3, 4 and 5. So y is a row vector whose first element is 1. That is what I have specified here, 1. It creates a range of values starting with 1 and the ending value is 5. and the middle value is representing the step size. So 1, if you add a 1 to this, you will get the next element, that is 2. Add a 1 to 2, you will get 3. Add a 1 to 3, you get 4. Add a 1 to 4, you get 5. So you can generate a range of values making use of the colon operator. Now, the default step size is 1. If you have generated y is equal to 1:5. This is equivalent to the previous statement. So from this you can make out that the default step size is 1. You can apply trigonometric functions, for example sine, cos, etc., as well as elementary math functions, that is square root, exponential, log, etc., onto the vectors term by term. So let's take a vector x. We have already created this. So you can apply any trigonometric function onto this. So if I say sine of x, this will compute the sine onto each and every element of your vector. So it computes like sine of 0, that is 0, and sine of 2.5, sine of 5, sine of 7.5, and sine of 10. Let's create a vector t equal to, I'm creating a range of values using column operator. So 2, starting element is 2, the step size is 2, and let the end element be 10. So this create a vector with elements 2, 4, 6, 8 and 10. You can compute the square root of t using the function sqrt. So this will compute the square root of each and every element of your vector. It computes like square root of 2, square root of 4, square root of 6, square root of 8 and square root of 10. So this is about vectors in Matlab, creating vectors and working out on few operations on vectors. Now let me show you an example where you are going to apply this. Consider this case. The equation of a straight line is y is equal to mx plus c, where m and c are constants. Compute the y-coordinate of a line with m is equal to 0.5 and the intercept c is equal to -2 at the following coordinates. So x is equal to, they have given a set of values 0, 1.5, etc. So to solve this, you can make use of the vectors and the operations on the vectors. So to solve this, let's first create our vector x with the following set of values. So we have created our x. So next, m is equal to 0.5 they have given, and the intercept c is equal to -2. This is also given. I have to evaluate the expression y is equal to mx plus c. So how will I write the Matlab equivalent expression? So y is equal to, m is a scalar and x is a vector. So I can simply write it as m into x. Same way, plus c is also a scalar. So I can write it as mx plus c. Let's evaluate this. So y is equal to m into x plus c. Yes, you can see your output here. So few more examples I'll be giving you for you to work out. I'll be giving the link in the description box. So please try it out. So we'll continue with matrices in the coming sessions. Thank you so much for watching. Please do like, share, comment and subscribe. And please don't forget to tap the bell icon. You'll get notified whenever we upload our new videos. Thank you.